So today we are going to discuss about the problem solving approach relating to potential due to spherical shell. Problem solving approach for potential due to spherical shell. So if I've got a spherical shell having some charge Q distributed uniformly throughout the shell, and the radius of the shell happens to be R, and I'm interested in finding out the potential at three different points. One point is, let me say, as X, which happens to be situated outside the shell, another point Y, which happens to be situated on the cell, and then another point Z, which happen to be situated inside the cell. So what will be the potential outside the shell, on the shell, and inside this shell? So if the point happens to be situated outside the shell, the potential is given by the formula 1/4 pi epsilon naught Q by X, where X happens to be the distance from the center of the shell to that position. Now if the point happens to be lying on the shell, so the potential of at a point on the shell will be equals to 1/4 pi epsilon naught Q by R, as this distance will be equal to the radii of the spherical shell. Now if the point happens to be inside the shell, then the potential also going to be equal to 1/4 pi epsilon naught Q by R, because during our theory classes we have seen that the potential remain constant inside the spherical shell. Now that point gives us the potential on the and inside to be equal to each other. The potential inside the shell remains constant, so it will be just equal to the potential on the shell. If we draw a graph to represent this thing, so you can see the origin represents the center, and this represents the point Y, which happens to be equal to R. So from the center till the surface, on the surface, the potential remains constant, and that value is, let me say, as V0, where V0 happens to be this particular value, that is 1/4 pi epsilon naught Q by R. So the potential on and inside is going to remain constant, and thereafter the potential decreases following inverse proportionality of X. So that is how the potential variation takes place. Now this has got several numerical problems based on to it. We would be discussing them in the separate classes.